Hi Rockbridge, this is Mrs. Berger, and today we are going to kick off Unit 5B. First day of the unit is on polynomials and substitution. So let's dive right in. We've just finished our project unit, our project-based unit on polynomials. So a little bit of this is repeat and a little bit of this is building on information we had earlier in the semester. Polynomials can be defined by their degree. And so we're going to fill in this table with our understanding of some polynomials that are very familiar to us, and then sort of extrapolate that knowledge into polynomials that may not be very familiar to us. So let's take a look at the first one, a polynomial of degree 0. That is a polynomial that is a constant, so we're going to call that a constant. And it looks like this in standard form. It looks like f of x equals, or y equals, some number. And we're going to call that number right now a sub 0. But there's no x here. Notice that a sub 0 is not being multiplied by a letter x. So an example of something that looks like this is y equals 3, or f of x equals negative 1. Okay? And so that is a constant. As we know, that looks like something like this, right? There's no slope, there's no variation. So that's a constant. That is a degree 0 polynomial. A degree 1 polynomial is a linear. Let me just finish this table for us and we'll look into the details in a second. A degree 2 polynomial, you know, is a quadratic. A degree 3 polynomial is a cubic. I bet you already knew that. And a degree 4 polynomial is a quartic. Quartic is a little confusing. It sounds so much like quadratic, so try not to get those mixed up. If we wanted to go further, we could say a degree 5 polynomial is a quintic. You can start to see the pattern there. So let's delve into what these look like. As you know, degree 1 polynomials look like this, or like this. And in standard form, it's f of x equals some number times x plus some constant. So an example might be y equals 3x plus 2. Or it could be f of x equals negative 2x. You don't necessarily have to have that constant term, right? A quadratic, as you know, it looks like this, or the upside down version of that. And in standard form, f of x equals some number times x squared plus some number times x plus some constant. So an example might be y equals negative 2x squared minus 4x plus 2. Actually, that's not a great example. Plus 1. You might also have, let me switch colors here. You might also have something that looks like this. F of x equals 3x squared minus 1. You don't necessarily have to have that linear term in the middle. As long as the highest power in the list is a 2, you're looking at a quadratic. So the highest exponent on those x's in that whole list of things is a 2, so you're looking at a quadratic. So similarly, cubic, we know what those look like from our last lesson. Highest power is a 3 in the entire list. And so an example might be y equals 2x cubed plus x squared minus x plus 4. I just made that up. Highest power in the list is a cubic, is a 3. And then quartic, as you saw in the last project-based unit, those kind of look like that in general. Highest power in the whole list is a 4. And remember, the power is on the x. So the highest power on the x is a 4, so that's why it's a quartic. And an example might be, I'm going to skip some terms here. Let's see. An example might be y equals 4x to the 4th minus 2x squared plus x. Okay, so I'm missing the cubic term as well as the constant, but that doesn't matter. The highest power on those x's is a 4, so I can consider that a degree 4 polynomial, a quartic. Okay, and I won't bother to fill in the quintic. You can see the pattern that's happening here. Okay, all right, so let's move forward and take a look at how do I know if I'm looking at a polynomial function. You're looking at a polynomial function if the powers on x are all whole numbers. That's how you can tell. So no negatives, no negative powers, and no variable powers. Right? So if I look at number 1, example number 1, is this a polynomial function? Is it a polynomial? I have a power of 2, that's fine. Power of 4, that's fine. And I actually have a power of 0 with this constant here. It's actually pretending like it's times x to the 0 power, right, which is 1. So those are all nice whole numbers, 2, 4, 0, those are all good. So this one can be declared a polynomial. So yes, this is a polynomial. Then they went further and asked us, what type of polynomial are we looking at? Well, remember, we look for the highest power in the list. Even though somebody wasn't nice enough to put this in order for us, we go search for the highest degree. That's a degree 4. Degree 4. So what did we call that? We called that a quartic. And the leading coefficient on that is a negative 3. So while we're here, I'm just going to talk about the fact that leading coefficient being negative means I'm down on the end. So that's kind of what it looks like. Just to practice that skill. Alright, number 2, is this a polynomial function? Does this pass the test? Well, 3 is a nice pretty whole number, but I've got exponent in the power there, or excuse me, variable in the power there, so that does not pass the test. So no, that's not a polynomial. Number 3, the 2 is fine, the invisible 1 is fine, but the negative 1 is not okay. So no, this is not a polynomial. And then number 4, look at number 4 carefully. The power on this is an invisible 1, that's fine. The power on this is a 2, that's fine. The power on this is actually x to the 0, right? That's fine. So this is actually, yes, it is a polynomial, because we don't break any of the non-polynomial rules. We don't break negative exponents or variable exponents. So yes, this is a polynomial. What type of polynomial is this? What degree do we have here? The highest degree is a 2. So we have a degree 2. That's a quadratic. The leading coefficient on that is pi, and it's positive pi. It's not gorgeous, right? That probably doesn't look very pretty, but pi being a leading coefficient, positive pi being a leading coefficient, means that this is an upward, up on the ends facing quadratic. Alright, so that's how you tell whether or not you have a polynomial and what type of polynomial you have. Now, let's shift a little bit into some more algebra, less of this high-level stuff, and let's dig into some algebra here. So we're going to talk about evaluating polynomials. We're going to discuss 2 different ways to evaluate polynomials today. One is something that you're very, very familiar with. You are very familiar with direct substitution. So if somebody said, if you look at question number 5, if somebody said evaluate f of 3 when you're given this function, f of x is 2x to the 4th minus 8x squared plus 5x minus 7, you already know what to do with that. You already know that in order to evaluate that, I need to what? Hopefully you said, I need to enter 3 every time I see an x, and you would absolutely be correct if you said that. So that action that you knew what to do is called direct substitution. So let's go ahead and do that now. Let's do direct substitution here. You will enter 3 every time you see an x. And then you'll evaluate. So take a moment and make sure that you use the correct signs on your calculator and go ahead and evaluate that. I'm going to pause the video and then you can check your answer after evaluating. Alright, hopefully you got 98. If you did not get 98, go ahead and pause it again. Make sure that you use your correct negative signs in your calculator. If you did get 98, let's go ahead and move to the other question that we have here for direct substitution. We're going to evaluate this one at negative 2. And so we're going to replace, every time we see an x, we're going to replace it with negative 2. Be careful on this on your calculator. I would definitely use parentheses everywhere to make sure that your calculator understands when you are bringing these negative numbers to these positive powers. So you should enter negative 2 to the 4th, negative 2 to the 2nd in for x. And go ahead and evaluate that as well, and then check your work. Alright, hopefully you paused the video and punched that in, and you should have negative 17. please pause the video if you did not get negative 17 and retry that. We want to make sure that we get these points on the quizzes and tests to make sure that we've got these skills down pat. Alright, so that was called direct substitution. Now I'm going to show you the second way that we could evaluate polynomials using synthetic substitution. Now I know 7 steps sounds like a lot, believe me, it will go much faster as we get into it, but let's just go through these 7 steps. So synthetic substitution is a way to do the same thing we just did, only with a quick and easy tool to break down the work for us. First, make sure your polynomial is written in order, in descending order. So make sure that you have the highest power on the x all the way to the left, and then it counts down from there. If you have a missing term in the list, so if you have a x to the 4th term but not an x to the 3rd term or so on, you'll place a 0 in as a placeholder, and I'll show you how that happens. We're going to copy down just the leading coefficients to start off our synthetic division. So let's go ahead and dive into this for example number 7 here so we can see these steps in order. So the first term is x to the 4th, then we have x to the 3rd, then we have x squared, and then we have x, and then we have a constant. So everything is in descending order already for us, and so that's quite helpful. And we don't have anybody missing, so we will go ahead and copy these coefficients down as they are. And that is step 3. Just write the leading coefficients. Since our polynomial is in order and we are not missing anything, we just took all the coefficients and copied them down. Now, we make this little L, and we're going to leave ourselves some space underneath the numbers. So make your L low enough that you have some space below the numbers. And then the number that we are trying to evaluate at, we're trying to evaluate the function of p at 2. That number goes right there on the outside. Okay? So now, step 4. Drop the first leading coefficient down. Take it as is. That one always happens. That's the only one that's going to happen for. Then, we're multiplying 2 times 3 and placing that answer right here. And I call that multiply up. Multiply up. Then, we're going to add down. What is negative 7 plus 6? That's negative 1. Now, we're going to multiply up again. Multiply up. 2 times negative 1 goes up here. Now I'm going to add down. Negative 5 and negative 2 is negative 7. Now I'm going to multiply up again. Multiply up. 2 times negative 7 goes up here as negative 14. Now add down. 9 plus negative 14 is negative 5. And then my last little multiply up. 2 times negative 5 goes up here as negative 10. Add down and I get 0. Now, circle the last solution here. That's the solution to the whole problem. P of 2 equals 0. P of 2 equals 0. So that was put all your constants up top, drop your first coefficient down, then go through and say multiply up, add down, multiply up, add down, multiply up, add down. Let's try it another time. But let's take a look at number 8 because we might have some things to check out for. Remember the steps 1 and 2 we had to check for some things. First of all, is everything written in descending order? Hopefully you yelled, no, it's not, it's not. It's not in descending order. So we need to place it in descending order before we get started. So n to the 4th should be first, and then the next one in line is negative 5n squared, and then positive 9n, and then plus 10. So that's a rewrite of s of n, that function, in descending order. So now we're good there. Now, do we have any missing exponents? You should be screaming at me, yes, yes, you do, you do. I have a power of 4, but not a power of 3. I have a power of 2, but and a power of 1, and a power of 0. So we're only missing the power of 3. So when I write my constants, I'm going to make sure that I leave a spot for that 0, for that missing power. So the n to the 4th power term has a leading coefficient of 1. It has an invisible 1. The n to the 3rd power was missing, so I need to put a placeholder 0. The n to the 2nd power has a -5. The n to the 1 power has a 9. And then the n to the 0 power has a 10. So now I'm going to draw my L, leave space. I'm trying to evaluate at -2, so that goes here. And now let's begin our work. Drop the 1 down, and then multiply up, -2. Add down, 0 plus -2 is -2. Multiply up, 2 times -2 is +4. -5 plus 4 is -1. Multiply up, -2 times -1 is +2. 9 plus 2 is 11. And then finally, multiply up, -2 times 11 is -22. 10 plus -22 is -12. And you can always check this with your calculator with direct substitution or direct evaluation. But if we trust ourselves, and we do for right now, s of -2 s of -2 equals -12. So that is what s of -2 is, using synthetic substitution. Okay, and you'll notice that we called this synthetic division up here. We're going to use this again on our division lesson, so that's why it's so important to get it down. Certainly we can always rely on our handy-dandy direct substitution on quizzes and tests to check ourselves, but I do need you to demonstrate that you're able to do this synthetic, because it is such a great tool for when we get to division next lesson. Okay, so on the quiz you will be asked to do both. You'll asked to do it with direct substitution as well as synthetic substitution, so make sure you know what those vocabulary words mean so that you can read the directions properly. Let me get you set up on the next one, and then I'm going to have you pause the video and try these 3 on your own. So let's work together to set the first one up. First of all, are the powers in order? Doesn't look like it. So let's make sure we get them in order before we do anything. So let's rewrite this as f of x equals -3x to the 4th minus 2x to the 3rd plus 3x squared minus x plus 4. Now everybody's in order. And I'm going to take my coefficients and line them up. I'm not missing anything. I've got a 4, a 3, a 2, a 1, and a 0 for all my powers. So I have everybody there. Don't forget that on this -x, the coefficient is -1. Make sure you feel comfortable with that the -x's coefficient is -1. And then I'm evaluating at -2. So there's my setup on that one. And then let me get you set up on the next one as well. We have a -5. Everything looks like it's in power order. I'm good there. On my setup, I have a -5. I don't have an x to the 4th term. I should have a 0 placeholder because I'm missing that x to the 4th term. I have a 3 on the x to the 3rd term. On the x squared term, I'm missing it, so it must be a 0. Oops, sorry about that. So it must be a 0. I have a -2 on the linear term and a -1 for the constant. And I'm trying to evaluate this whole thing at 3. Go ahead and try A, B, and C. So you have those setups. Pause the video and go ahead and try A, B, and C, and then restart the video to see the answers. Alright, so hopefully you had a moment to work on that. Go ahead and check your work here. I've included my work so that you're not just looking at the answers. You can see the in-between answers. Notice that it's a lot of attention to detail, right? Even little silly mistakes like negatives and positives will throw us off. But hopefully you got -14 for A, -1141 for B, and 0 for C. One other little note I'll have is notice some of the scenarios where it makes more sense to do direct substitution In other scenarios, it makes more sense to do synthetic substitution. I think C, for part C, there's certainly a case to be made for just simply direct inputting -4 into each of those terms. It might have been a little faster. Maybe not, depends on how fast you are at synthetic. But there were a lot of zeros in there, and so we had some setup steps that might have taken time away. So that's the kind of decision you can make on a big, end-of-year test like an SOL. But we'll certainly want to have you demonstrate both of these methods, or yes, both of these methods, direct and synthetic. Alright, make sure that you have the sound on whenever you're watching all of these videos. And today I would like you to go back and put a giant circle around the words "you try." So go ahead and circle the words "you try." And at this point, please go ahead and try your day 1 homework. That's your day 1 practice for this, and let us know if you have any questions.